Hello learners, welcome to Swam course on CAD CAM. I am Dr. K. Tamil Manan, Associate Professor, Mechanical Engineering, Indira Gandhi National Open University, New Delhi. Today we are going to discuss the topic on computer-aided design, geometric modeling. The geometric modeling is one of the major component in the CAD software. What is geometric modeling? Geometric modeling is an integral part of computer-aided design system, which is inbuilt in the CAD system. Geometrical model is defined as complete representation of graphical and non-graphical information of object or images. So the geometric model is defined as its complete set of graphical information or non-graphical information of the objects. Geometric modeling provides a user to construct a geometric model of an object in the CAD/CAM system by inputting the object data. The geometric modeling provides the user to construct the various geometric model of the object images by inputting the object data, the required corresponding object data. The data required for modeling technique is provided through the user interface systems. Geometric modeling is a branch of applied mathematics and computational geometry that studies various methods and algorithms for the mathematical description of the shapes and images. So geometric modeling is basically the branch of applied mathematics and computational geometrical studies. The methods and algorithm for the mathematical description of shapes. So the computational geometry study of various methods and algorithm for the mathematical description of the various shapes and images in the CAD systems. The software then converts such data into mathematical representation, which is stored in the model database for later use. Whenever it's required, it can be retrieved then for the creating the geometrical images. The user may retrieve and edit the model during the design or manufacturing the process using the model database. The required and relevant data can be stored in the model database. Whenever it's required for design or manufacturing process, it can be retrieved from the model database. In geometric modeling, it's mainly that it has classified the two-dimensional techniques, two-dimensional modelings. One is two-dimensional modeling, another one is three-dimensional modelings. In two-dimensional modeling, the 2D model sufficiently and accurately describe the part geometry. So it's in two-dimensional modeling, it represents in the only the part geometry. The two-dimensional system shows coordinate data with x and y values, so that it indicates only the x coordinates and y coordinates. 2D geometrical model is a geometrical model of object as two-dimensional figure, which is shown in that object here, usually based on the Euclidean or Cartesian plane coordinate systems. In 3D geometrical modeling, 3D modeling is another geometric modeling techniques. Basically, the transformation is a process of modifying and repositioning in the existing graphics. The existing images, existing objects can be modified and repositioned in the existing objects or graphics. It's called the process is called transformations. 3D transformation. In 3D transformation takes place in three-dimensional planes. The three-dimensional object or plane can be repositioned or scaled or rotated through the existing plane. This is called the 3D transformation plane. 3D transformation are helpful in changing the position, changing the size, changing the orientation and shape of the object. 3D model represents the 3D object using the collection of points in 3D space connected by various geometric entities such as triangles, lines, curved surfaces, etc. Classification of modeling. In general, the modeling is basically classified in wireframe modeling, surface modeling and solid modeling. The wireframe model is also called as line modeling and solid model also is called volume modeling. This image shows that these are this indication of wireframe modeling. This figure shows the indication of surface modeling. This figure shows the indication of solid or volume modeling. It's called solid modeling. What is wireframe modeling? What is the purpose of wireframe modeling? Wireframe model is a basically simplest geometrical model that can be used to represent the object mathematically in the system. So that basically it's a simplest geometrical model which can be represent the outline of the object in the system. It is also called line model or edge representation model of the object or images. Typically, the wireframe model consists of the various primitives such as points, lines, arcs, circles, conics and curves. The edge may be straight line, arc or any other well-defined space curve. The wireframe model of a three-dimensional object consists of finite set of points together with the edges connecting the various pairs of these points. This figure shows that the wireframe model, three-dimensional wireframe model, consists of finite sets of points is connected together with the edges and connecting the various pairs of these points. For constructing wireframe models, the following entities are used. So that the cubic splines, B-splines and Bezier curves. These three entities are used to construct the wireframe modeling object or blocks. The cubic splines. The cubic splines is the curves with the parametric intervals defined at equal length. It can be defined at the equal lengths. So that the distance between the one point to another point, it should be equal distance. It passes over a given set of data points from start point to the end point slopes. So it passes over all given set of points from P to P1 to P2, P3, P4, P5, P6 and P end points. See, from the P starting to the start point to the end point of the curves. The cubic splines do not allow the user to change the smoothness of the curve. The cubic splines, it's not allowing the user to change the smoothness of the curve. Next, the Bezier curve. Bezier curve is a polynomial curve defined by the set of control points that are used approximating the generating curves. The curve will pass through the first and last point with all other points pointing act as a control point. This figure shows the P0 and P3 and B1 and B2. The curve passes through the first and last point, and last point will all other points acting as a control point. This is the B3 shows the control points. This distance between the B0 and B1 is the control polygon. Bezier curve exhibits a global control curve. Whenever the single vertex in the control polygon is moved, the entire curve will be affected. The flexibility of the curve becomes with more control points. If you increase the more control points, automatically the flexibility of the curve will be increased. Some important advantages and merits of wireframe modeling, such as it is easy to construct. The image has been easy to construct. We can construct the image very easily. It needs less memory space. Generally in wireframe modeling requires only less space to store the data. It takes very less manipulation time. So therefore it's consuming the very less time for manipulation, the images or objects. It does not require any extensive training for users. It is very simple. So it does not require any specific or special training for the users. It is the best suitable for manipulation as orthographic, isometric and perspective views. So the wireframe modeling is best suitable for these all geometric primitives such as orthographic views, isometric views and perspective views. Also, wireframe modeling having some demerits or disadvantages. There is more doubt in the identify the surfaces. So we cannot identify the surfaces very quickly, accurately. The images of wireframe model cause confusion to the viewer. So that the images of wireframe model, it should be that it makes the confuse and conflicts the viewers. We cannot accurately see the images of the wireframe model. It's not possible to calculate the mass properties. We cannot calculate the mass properties of the wireframe model because it doesn't have that mass, volume, etc. It is not useful for NC toolpath generation, cross-sectioning, interface reductions. So it's not possible, it's not useful for the manufacturing and numerical control machines manufacturing also it's not possible. It is not suitable for representing the complex solids. So the complex shape of solids cannot be represented by using the wireframe model. The hidden line removal is a time consuming task. So the hidden line removal in that wireframe modeling also it takes a lot of time. Both topological and geometrical data are required for wireframe modeling. So if we constructing the wireframe modeling, we need that both topological as well as geometrical data to construct the wireframe modeling. So this figure shows the images of the wireframe model. So it's not be realistic. It's ambiguity because it's not very clear. So it's very difficult to that complex shapes cannot be for interpreting the complex shape. It's very difficult because if that image of the wireframe model image is not clear. It's ambiguity. Another one is the surface modeling. So the another type of modeling is called surface modeling. What is surface modeling? The surface model is an object is more complete and less confusing representation than its wireframe model. When it is compared to that wireframe model, the object is a complete object and it takes only the less confusing representation compared to the wireframe model. It is a surface model can built by defining the surface on the wireframe model. Already we construct the wireframe model, so it provides the surface to that wireframe modeling. The procedure of constructing a surface model is stretching the thin piece of material over a framework. This is the principle of constructing the surface model. Stretching the thin piece of material over the framework. The image shows the surface modeling techniques. There are various types of surface modeling. Various types of techniques are used in that surface modeling to create the surface modeling. This plane surface. This is the simplest flat D surface. It requires 3 non-coincident points to define a infinite plane. So there are 3 non-coincident points which is required for define this infinite plane surface. Another one is a tabulated cylinder. This is a surface generated by translating a planar curve a certain distance along the specified direction. So that particular distance and specified direction it can be translated a planar curve. Next, the ruled surface. The ruled surface is constructed by transitioning between 2 or more curves by using linear blending between each section of the surface. This is used to generate the surface do not have any twist. There is no twist in the ruled surface. Another type of the surface modeling is the surface of revolution. The surface of revolution is an axis symmetric surface. This is an axis symmetric surface. It is generated by revolving a planar wireframe entity in space about axis of symmetry at certain angle. It is generated by revolving a planar wireframe entity in space about an axis symmetry at certain particular angle. It is generated revolving a planar wireframe entity in space about an axis symmetry certain angle. So other types of solid modeling, the swept surface. This surface is produced by sweeping the defining curve along the arbitrary spline curve instead of a circular arc. So instead of circular arc, the arbitrary spline curve is used for defining the sweeping surface. So it's a swept surface. The sculpture or curved mesh surface. This is a surface produced by a grid of geometric curves which intersects to form a patchwork of surface patches. So that during the patchwork of the patches, that the surface is produced a grid geometric curves which is helps to create the patchwork of the surface. So it's called the sculpture or curved mesh surface. Another is the fillet surface. It is a B-plane surface that blends two surfaces together. The original surface may or may not be trimmed. Another is the Bezier surface. This is a surface that can be generated approximately with the given input data. It is a synthetic surface. It is a general surface that permits a twist and blends. So it can be permit the twist. We can twist it. Also we can make bends. These are some images of the various objects: the plane, tabulated cylinders, surface of revolution, ruled surface, swept surface, curved mesh surface, fillet between plane and cylinder. And B-spline surface. This surface allow any global control of the surface. It can be used in open boundaries. These open boundaries we can use the B-spline surface technologies. This surface can be generated approximately or interpolate with the given set of input data. So the given set of input data, the surface can be generated approximately or interpolate with the object. It is a synthetic surface. This surface exhibits a local control. It can be used in open boundaries. Next is a cone surface. Cone surface or patch is obtained by blending four boundary curves. If you blending the four boundary curves, we can have the cone surface. This figure shows the four surfaces, four boundary surfaces such as C1, C2, C3 and C4. So the closed boundary, it can be that batched it, and we can have the cone surfaces. The cone's batch surface is generated by the interpolation of four edge curves as shown in the figure. The blending of these patches can be done either by means of linear or cubic blending function. By using the linear or cubic blending function, we can have the blending of patches. This gives a smooth surface linking the all patches. Another one is the offset surface. Existing surface can be offset to create new surface. So we can using the offset surface, the existing surface can create the new surface. The offset surface is an identical shape with the existing surface. It should be identical with the existing surface. It may have the different dimensions. Offset surface have the different dimensions. It is used to speed up the surface constructions. It may use the speed up the surface construction. This image shows the offset surface, and existing surface can be offset surface to create the new surface. Application of surface modeling. There are various types of application for that surface modeling. In surface modeling is generally used in following application, such as checking the interference between the matting points. If there are two matting points in the objects or images, that there are interference occurs between the two matting points, that can be checked by using in the surface modeling property. In generating cross-sectional views, in surface modeling we can create the cross-sectional views. Generating finite element meshes. So finite element mesh can be generated in the surface modeling. Generating NC tools paths for continuous path machining. So that surface modeling can generate the NC tool paths for continuous path machining. Also, the surface modeling can have for finite element analysis. Finite element analysis is a method of predicting behavior of real structures under various load and displacement conditions. So that the finite element analysis can do in the surface modeling of the object or images. Some other merits of surface modeling. The surface models have the less confusing than wireframe model. So when compared to that wireframe model, it have the less confusion, because that the surface is very clear compared to that wireframe model. They provide hidden line and surface algorithm to add the realism to the displayed geometry. To display the geometry in surface modeling, it's provide both hidden line as well as surface algorithm, so that we will get the reality of the images and pictures or objects. So shading algorithm also are available to make the surface modeling. Some various demerits of surface modeling are, so also the surface modeling have some disadvantages, such as the interior detail of the model cannot be represented. So that in surface modeling, the interior details of the object or model, which it's very difficult to represent. We cannot be project on the interior surface of the modeling. The designer requires more training and mathematical background. When designing the surface modeling, so that when designers require the more mathematical knowledge and mathematical based training. It takes place more time to create. Surface, when compared to wireframe modeling, the surface modeling takes more time. It's a time consumption process. It requires more storage capacity. When compared to wireframe modeling, it requires more storage for the storing the various types of images and objects. It requires more manipulation time. For manipulation of the image or object also, it requires more time. The construction is not simple as wireframe model. When compared to the wireframe model, the construction of surface modeling is not much simple. The figure shows the surface modeling. The surface model provides no information about the inside of object. So the inside object information, it will not be provided in the surface modeling. Cannot be used to calculate the dynamic properties. So the dynamic properties cannot be calculated in the surface modeling. Learners, we have discussed the various topics in geometric modeling, such as there are various types of what is geometric modeling and what are the geometric modeling techniques. There are the two types of geometric modeling, such as two-dimensional model and three-dimensional models, and how the modeling has been classified. So that is wireframe modeling, surface modeling and solid modeling. So we have discussed this wireframe modeling and surface modeling. The solid modeling we discuss in the next lecture. In wireframe modeling, there are a lot of various techniques are used to construct the wireframe modeling, such as cubic splines, Bezier curves, B-splines, wireframe model with linear edges, wireframe model with curvilinear edges, and various types of merits and demerits of wireframe modeling. There's advantages and disadvantages of wireframe modeling. Also, we have covered in this topic surface modeling. What is surface modeling? What are the various types of surface modeling? And that what are the techniques used in surface modeling to construct the surface of the images or objects, such as plane surface and curved surface are used to construct the surface modeling of the object or images. So there also we discussed the various types of surface modeling techniques, and also we have discussed the application of surface modeling, where we can use the surface modeling, how we can use the surface modeling, what are the various industrial applications, and also what are the various merits of the application, what are the advantages of the surface modeling, also what are the disadvantages of the surface modeling. So in this geometric modeling and CAD, we have different books for further readings, such as CAD Cam Sim by Radhakrishnan P, and CAD Cam by Gruer Michael P and Zimmers Emery W, CAD Cam by Principle and Applications by P.N. Rao, and Mastering of CAD Cam by Ibrahim Said. So these are the books, important books we can have for further readings. Listeners, hope you understand about the geometric modeling. Thanks for listening.